Welcome to the Year 12 PPE question 8, and this question is about exponential decay, more particularly a cup of tea on a table that's cooling down according to this formula here. Okay, so in question A we have to find the temperature of the cup of tea when it was placed on the table. In other words, when T equals 0. So theta would simply be 18 plus 65, okay, times e to the power of 0, okay. Well, e to the power of 0 is 1, so that's simply going to be 83 degrees C. Okay, so it's a really easy question to start, just for 1 mark. Okay, now question B is asking us to use the same formula but in a different order. We're given the value of theta as 34, and we know that that comes from 18 plus 65 times e to the power of negative t over 8. Okay, and we've got to find t. And by the way, this is negative t here. It just looks a bit like the fraction line has absorbed the minus sign, but just to be clear, that's a negative t over 8. Okay, well, basically we need to solve this. So if we take away the 18 from both sides, we get 65 e to the power of negative t over 8 equals 16. Okay, if we now divide by 65, we get e to the negative t over 8 equals 16 over 65. Okay, and then if we take natural logarithms of both sides, we get minus t over 8, okay, equals the natural logarithm of 16 over 65, and therefore we just need to times by negative 8 now to get t. Okay, so t equals negative 8 times the natural logarithm of 16 over 65. Now you don't need to do any more with that because you need to evaluate that on the calculator. Just put it in as it is, and that will give you that t equals 11.2 minutes to 3 significant figures, which is a suitable degree of accuracy for a question like this. Okay, 11.2 minutes there. Okay, right, and now part C, and what it's asking here is explain why the temperature could not fall to 15 degrees C. All right, so in other words, what we're looking for is the line, the horizontal line that the temperature approaches but never quite reaches. By the way, this graph is a different situation to the one described here, which comes up in part D of the question in a minute. So let's consider this. So what we can say is, after a long time, that's when the temperature of the tea is going to be at its coolest. So we consider what happens as t approaches infinity. Okay, it doesn't reach it, it approaches it after a very long time, and at t approaching infinity, e to the power of negative t over 8 doesn't ever reach 0, but it approaches 0. It gets very, very, very close to 0. Okay, and therefore theta approaches 18. Okay, because you've always got this little bit added on to 18, so it's always above 18 but getting closer and closer and closer to it. And we actually say that it approaches 18 from above. Okay, it's quite important that it's clear that it's approaching 18 from above. Okay, so what we can conclude is that theta is greater than 18. Okay, therefore theta cannot equal or cannot be 15, or some conclusion similar to that. Okay, and that answers part C. Now, on the next screen, we go to part D, which uses this graph, and I've reproduced that on the next page. Okay, so this is how it works. We've got a different cup of tea in a different room on a different table, and it follows the same sort of equation, but we've got different constants A and B to find. And this cup of tea starts at 94 degrees when it's put on the table. So we can say from this that we have, so using this equation here, we can say that A, okay, plus B. Now, when the time is 0, okay, when the time is 0, the temperature is 94. So BE to the 0 equals 94. Well, e to the 0 is 1. So that implies that A plus B equals 1. A plus B equals 94. Okay, and that's equation 1, I'm going to call that. Okay, and then I can do the same sort of thing for the point 850. So A plus B e to the power of, now this time t is 8, so it's negative 8 over 8, which is negative 1, and that equals 50. Okay, and therefore, well, I'll just call that equation 2. Okay, equation 2 as it is. Now, if I subtract equation 1, take away equation 2, okay, that will give me, 94 minus 50. A minus A is 0, so it will give me B minus B e to the negative 1 equals 44, because the a's have cancelled when you subtract the two equations. And that can also be written as B brackets 1 minus e to the minus 1 equals 44. Okay, now from equation 1, okay, so from 1, I can also say that, okay, that A is 94 minus B. So I can say that A is 94 minus B, okay, and B is going to be 44 over 1 minus e to the minus 1, okay, 44 over 1 minus e to the minus 1. So what I'm doing is I'm replacing B with just rearranging this one here. Okay, now I know that from the equation given here that mu is equal to A plus B times e to the negative t over 8. Okay, now the asymptote is the horizontal line down here, and we've got to find the equation of that. Now the curve approaches that line as t tends to infinity. So what we can say is that as t approaches infinity, okay, mu equals A plus, well, you see, as t gets to be a very large negative number, so minus a very big number over 8, then this approaches 0. So it just becomes A plus 0. Okay? Which implies that mu equals A, which is 94 minus 44 over 1 minus e to the minus 1. Okay, so that's where that comes from. Now what I've got to do is to find an equation for the asymptote L. Well, I've kind of done it already just by writing that down. I can tidy that up a little bit if I put a common denominator of 1 minus e to the minus 1. So I can say that mu equals, okay, 94 1 minus e to the minus 1, okay, minus 44, and then that's all over a common denominator of 1 minus e to the minus 1, okay. And if you rearrange that a little bit further, you can tidy it up to get 50 minus 94 e to the minus 1, 50 minus 94 times e to the minus 1, okay, over 1 minus e to the minus 1. Now you may be thinking, do I need to do all this? Well, it's normally a good idea just to tidy it up as best you can, and it won't hurt to do some practice at this kind of thing. So we'll finish this off. There's one more step I want to do after this. So that is the second to last step, 1 minus e to the minus 1. Okay, now remember 1 minus e to the minus 1 is 1 minus 1 over e. So if I multiply the numerator and denominator by e, okay, that will give me a much tidier fraction without all those negative indices in it, and it will give me 50e minus 94. Okay, so I'm basically multiplying the whole of the numerator by e, and the denominator, when you multiply it by e, will give you e minus 1. Okay, and that's a bit neater than the original form of the equation that we had here. Or here. Okay, so I'm not sure that you would need to do that because it does say find an equation for the asymptote L, but I would suggest that is the best form for the answer. Okay, hope that was helpful.